Okay, so we are doing lesson 4-0 here, which is kind of meant to be a refresher on how to graph linear equations, because our new chapter, chapter 4, is going to be dealing with systems of equations, where we're going to have multiple equations like this. And the first part is about how to graph them. So we did graphing over the adaptive pause, and I felt that doing a refresher would be beneficial to us. So what we have here is y equals 2/3 x plus 3. This takes the form of a linear equation in slope-intercept form. And hopefully you remember slope-intercept form to be y equals mx plus b. B is the y-intercept. This is the part on the y-axis, okay, the axis going up and down. This is the part where we start. So I would call this our starting point. M is our slope, and that determines how steep the line is, and I like to think of this as the directions. So once we have our starting point from the y-intercept, we follow our directions to get us to the next point on our line. And all you need to draw a line is 2 set points. You can have more, but you need at least 2. So looking at our example right here, it appears that our slope is 2/3. And you can tell that 2/3 is the slope because the slope is always next to the x variable. So our slope is 2/3. And then our y-intercept is the part that doesn't have the variable. So it is 3. B is 3. So how can I use this to draw my line? I'm going to start at the y-intercept. On the y-axis, I want to put a dot at 3. So that's what I'll do right here. There's my dot at 3. Now I need to follow my slope, which is our directions. And notice that it is a positive number. Because it is positive, that means both the x direction and the y direction are going to be positive. So y is on top, so we're going to go up 2, and then 3 is on the bottom, so we're going to go over 3. So from our starting point, I'm going to follow that slope. First is going up 2, and then I'm going to go to the right 3. So up 2, right 3, and I'll put my next dot there. Okay, and I can do it again. Up 2, right 3. And notice how they look kind of like they're in a straight line, and that's what we want. We want them to look like you can connect them using a ruler or some sort of straight edge. So I'm going to use a index card as my ruler. I'm going to line up my dots as best as I can, and then I am going to draw my line through them. And that is our linear graph of our original linear equation, y equals 2/3 x plus 3. All right, so let's try another one. Over here, I have y equals negative 1/3 x minus 4. So it's kind of the same as what we did over here. It's in slope-intercept form. All the ones we do in this video will be slope-intercept form. So first, let's state what our slope is and what our y-intercept is. The slope, remember, is always next to the x, so that's going to be negative 1/3. The y-intercept doesn't have the x, and this is going to be a negative 4. So from here, we'll start by putting a dot at negative 4 on the y-axis. Okay, so negative 4 right there. Now we're going to follow our slope, and notice that the slope is negative. And because the slope is negative, that means one of the directions we go has to be in the negative direction. For y, negative is down. For x, negative is left. But we don't want to go down and left because then both directions are negative. So I like to think of the negative sign as determining up or down, and then the bottom always being positive. So I would say that we would go down 1 and to the right 3, because down is negative in the y direction and right is positive in the x direction. So starting at our -4, we're going to go down 1 and to the right 3. 1, 2, 3. Down 1 and to the right 3. Now, I'm going to also put in here, instead of going down and to the right, you also technically could go up and to the left. Okay, because look, if I'm starting here and I want to get to the point over here, I can go up 1 and to the left 3, up 1 and to the left 3. And then I can even create more dots that way, up 1 and to the left 3. And once again, that dot looks like it's in line with the others. So we have some options. I think it's easiest if you always think of the negative going with the top number and then the bottom number always being positive. But if you run out of room, you might have to go in the reverse directions. So let's create our line with our ruler here. Okay, not perfect, but it's decent. Since this is a line, we should put arrows on the ends of it because lines extend in both directions forever. And there we go. We have graphed our second example in slope-intercept form. There's 2 more we want to go through though, just because there's lots of different possibilities of how these could look. So let's take a look at number 3. This one has y equals 5x. Now, what do you notice about this example? Hopefully, you notice that if we were trying to compare it to y equals mx plus b, okay, if you're trying to compare it to y equals mx plus b, we don't have a b value. It's missing. So you have 2 options here. You can either just remember how to handle these, or you can think of it as a plus 0. If it's not there, it's 0, so we can add it as a plus 0. That means my starting point is at the origin. My starting point is going to be right here. Now, for the second part, for my slope, okay, our slope is 5. But the slope, remember, needs to tell us how many up or down, and then how many left or right. So it's best when our slope is a fraction. And any whole number can be written as the whole number over 1. And that's what we want to do when we have a whole number slope, is we're going to write it as a fraction over 1. Now this is a positive 5, so I'm going to be going up 5 and to the right 1. I want to go positive in both directions here. So starting at my origin, my y-intercept of 0, I can go up 5 and to the right 1. Up 5 and to the right 1. Now, just like we saw in the second example, I could reverse these. I could go down and to the left. And the reason that can happen is because negative on the y-axis is down, negative on the x-axis is left, so a negative with a negative gives us a positive. And I would only want to do this if I run out of room and I need to get another dot. So I can go down 3, 4, 5, down 5, and to the left 1, and that looks like it is going to follow the same line as the others. So let's get our note card here, connect them up best as I can. And there we go. There's our third example, our third line. Finally, what if they give you a decimal as our slope? Okay, so I have y equals 0.5x plus 2. My slope is 0.5. My y-intercept is 2. So nothing changed on the y-intercept line. We're just going to put our dot at 2. But how am I going to interpret the decimal? Well, the answer is you're not going to. You're going to change it to a fraction. You want to use your calculator or your brain if you know how to do some easy decimal to fraction conversions. So 0.5 is the same thing as 1/2. And now that I have it as a fraction, I can tell what direction how many I'm going up or down, and how many I'm going left or right. So it's positive, we're going up 1 and to the right 2. Starting at this point, up 1, to the right 2, up 1, to the right 2, and so forth and so on. And then once we have at least 2 dots, we can do more, but you need at least 2. Get your ruler, connect them, and we're good to go. All right, so there's the end of part 1 of our little review on graphing these linear equations. And these were all in slope-intercept form, the easiest way to graph them. What we'll see in the next part is how to graph if we are given standard form. So see you there.